Hey guys, I'm feeling like a double-double. Anybody want one?
I do.
We better get going.
Nice.
Let's go.
Oh my gosh, what is that?
It looks like an outline. I think someone got murdered.
What's this water doing here?
It's definitely fresh.
Wait, is that a bucket?
I think it is. We should get a sample.
Looks like we've got ourselves a murder mystery. Burgers can wait.
Okay, so what do we know?
Well, we have a sample of water, so we're gonna go see if there are any clues in it.
Let's go.
Well, what just happened?
I don't know. Must be a power outage.
I can't see the sample anymore. However, I did notice in the water that there were tiny claws, 8 little limbs, and a segmented body.
Did you see any symmetry?
I think there was some bilateral symmetry.
Belinda, let's go see if we can get a DNA analysis ready while Xander and Scott get the power back up.
The power's been restored, but have you heard anything from Julie and Belinda?
No, I haven't. Wanna go look?
Let's go.
Let's go. Oh my gosh. Are they dead? Wait, what is that? Oh my. They got the DNA. And they looks like every other piece of DNA from the phyla that we analyzed in class as well. I think we got it.
Volcanic rock and freshwater moss? What a specific set of habitats. I need to text Xander.
Okay, so the unknown DNA sequences seem to match those of the Tardigrada phylum. Scott mentioned that the habitat has freshwater moss and volcanic rock. Tardigrada also matches that habitat. They prefer fresh water, but they can live in extreme heat and extreme cold. That explains the ice. Hold on. Let me start writing out some phylogenetic trees and see how this phylum attaches or matches with the others in lab. Porifera had the least amount of similarity in the data matrix characteristics when compared to Tardigrada. Therefore, it is the outgroup in our data matrix tree and our 16S DNA tree. Both trees have 7 evolutionary changes when following the proposed path of Tardigrada. Our literature tree and our 16S DNA tree are different because our 16S DNA tree analyzes the 16S DNA region, while the literature tree analyzes the ITS2 DNA region. When comparing the 16S DNA tree to the ITS DNA literature tree, there are many similarities between them, such as the close relation of Arthropoda to Tardigrada via a common ancestor, the labeling of Echinodermata and Chordata as sister taxa, with Echinodermata represented as more removed from Tardigrada is also a similarity. Thus, according to the literature tree, Tardigrada is most closely related to Arthropoda, and scientists propose a close relation to Nematoda. Some additional information includes the evolution of Tardigrada. Tardigrada is hypothesized to be evolved from Lobopodians around 500 million years ago. Lobopodians have a centipede-esque shape, which is similar to the physical characteristics connecting the entire clade Ecdiozoa, including the phylum Tardigrada. Additionally, we propose that our data matrix tree could be inaccurate compared to the literature tree because the data matrix does not take into account convergent evolution. This all makes sense. Now it's just time to call the police.
Hello?
Tardigrada consists of 2 to 3 species of tardigrades, eutardigrada, heterotardigrada, and mesotardigrada, that have slight differences, like having a different number of legs or claws. They are capable of living in essentially any environment, in volcanic vents, on the bottom of the ocean, in Antarctica with extreme colds, and even in space because of their ability to perform cryptobiosis. Their preferred environment is freshwater mosses, which is why they're sometimes called moss piglets. Tardigrades reproduce either via asexual or sexual reproduction by laying little spiked eggs, and the spikes help the eggs attach to surfaces, so when the tardigrades hatch, they can emerge in a relatively stable environment. Some tardigrades have both male and female anatomy and can reproduce asexually or sexually. Other tardigrades only have one or the other. A tardigrade diet consists mostly of different kinds of mosses and algae, and occasionally on smaller invertebrates in their environment. Interestingly, the amount of food a tardigrade eats before giving birth seems to determine the amount of offspring produced, which generally ranges from 1 to around 30 offspring. They move by crawling with their little legs, which is very similar to insect movement. Tardigrade's life starts when they hatch from eggs, and their lifespan can last between a few months to a few years, depending on the species and if they perform cryptobiosis, which can extend their lifespan by many years. They spend the first portion of their lives eating and gathering energy to grow and shed their skin, which happens 4 to 12 times before reaching adulthood. Their relationship and value to humans is due to their ability to perform cryptobiosis and surviving in extreme temperatures and conditions. They're often used as a model for studying biological survival in extreme conditions. Some studies have looked at how tardigrades can survive in space, which can hopefully be applied to understand how humans can better survive in space. Tardigrades are protozoans, which means that their mouth developed before their anus in the embryo. They have true tissues and are bilaterally symmetric.